Сочный дым, выдыхаем сладкого. Старый капитан опускается за бабками. Веер из купюр.
Here's a myth we love to tell. Einstein was never wrong. Here's the physics. Einstein published Knowing He Could Be. That's science at its best. In the 1910s, Vesto Slipher looked at fuzzy smudges in the night sky and saw their light stretched, redshifted. Later, Edwin Hubble connected that redshift to distance. The farther the galaxy, the faster it seemed to recede, not because galaxies were blasting through space like rockets, but because space itself was expanding between them. That's the first big distinction. Motion through space, the expansion of space. Special relativity says nothing with mass can locally outrun light. True. But the universe plays a different game at cosmological scales. Space can expand at any rate, so distant galaxies can recede from us faster than light without breaking the rules. No one is locally overtaking a photon. Think of a loaf of raisin bread rising. The raisins don't sprint, the dough stretches. Slipher saw the stretch in light. Hubble mapped the stretch in distance. Einstein originally tried to stop this cosmic rising with the cosmological constant to keep the universe static. When the data said, nope, it's expanding, he called it fix his greatest blunder. The twist, today the cosmological constant, dark energy, is our leading explanation for why the expansion is not just happening, but accelerating. Now about inventions. Starships drives daring ideas. The speed limit C applies to motion through space in your local frame. If I floor a rocket, relativity makes the energy bill explode as I near light speed. I don't get to see, but there's a clever loophole. Change the stage, not the dancer. Warp concepts like the Alcubierre drive don't push a ship faster than light. They distort the metric of space-time. Contract in front, expand behind. Inside the bubble, the ship is locally at rest, obeying relativity. Globally, the bubble rides space-time surf. That mimics cosmological recession without breaking the local rules. Does that mean inventions aren't subject to the same laws as planets and galaxies? The laws are universal, but the mechanisms matter. Celestial bodies mostly coast on gravity within the existing geometry. A hypothetical starship would try to engineer geometry itself. Metric engineering, same laws, different lever. Here's where your brain picture helps. If the universe is a brain, our 3D world embedded in a higher structure, expansion is the brain's geometry changing. Redshift is light getting stretched as it crosses that geometry. Precession rates faster than C are a property of the brain, not of rockets. Now, your nodes idea asks, what if we can grab the brain at specific points? Nodes, where gravity and quantum meet. If such nodes are real and manipulable, a craft could sculpt space-time on demand. That's warp without motion. In modern language, seek regions where the gravitational field's metric can be engineered with exotic energy densities, negative energy, Casimir-like effects, quantum vacuum tricks. Do I think gravitons and nodes are the link? If gravity is quantum, the graviton would be the carrier. But we haven't detected it, and a full quantum gravity theory is unfinished. So today, nodes are a provocative metaphor. Tomorrow they might be coordinates in a working metric. Myth versus physics. Einstein wasn't toppled by Hubble. He was refined. Motion through space is limited. Expansion of space isn't, and the future of propulsion may not be about going faster, but about making here and there trade places. That's not breaking the rules. It's learning to write with them. What really stops anything from outrunning light? Think less about speed, more about how interactions propagate. A universal refresh rate for reality sets the pace. Call it a propagation constraint. No influence jumps ahead. It sounds exotic, but it stays faithful to relativity. Galaxies aren't flying through a void. Space itself expands. Redshift is light, stretched by that expansion. Recession rates can exceed c without breaking relativity. Locally, nothing outruns a photon. Globally, the map stretches. Points move apart because the sheet grows, not because they sprint. No preferred frame. The speed of light stays invariant. Classical mechanics reappears in the right limits. At everyday speeds, the universe feels Newtonian. Push harder and relativistic timing matters. The constraint is simply the rule book for causality. Picture a brain, the fabric that carries everything. Recession is the grid enlarging underfoot. No galaxy overtakes light locally. Spacing increases globally, like lanes elongating while cars keep their lanes. So far, nothing violates Einstein. Now add a twist. Discrete nodes transmitting state. Each node flips at a finite rate. The reset rate. Acceleration demands faster flips. Velocity pushes the clock. At light speed, the grid hits its maximum refresh. No faster than light signals, because the network can't flip faster. This model splits gravity into two parts: geodesic space, local motions, planetary accelerations. 0 point space field, the global propagation scaffold. Local density sets small a. C is the universal ceiling. Same field sets limits from planets to photons. Propagation rides discrete nodes like a ticking grid. Smooth at low A, faster motion, faster state transitions, push velocity, and the grid works harder to keep up. At C, refresh saturates. Beyond, updates can't propagate. Gravity then is the low speed face of that same mechanism. Trade curvature, wells for expanse pressure, flow not fall. Orbits become tracks defined by pressure balance. Planets glide in channels of equal propagation pressure. No ongoing energy to bend space. The stage stays stable. Same rules from solar systems to galaxies. A 2.1 expanse ratio sets a dominant pressure direction. It aligns planes, establishes stable orbits, needs no dark glue. Planar systems emerge from pressure anisotropy. Bodies follow geodesic channels, balanced flow paths. Think high-pressure conveyor, not a rubber sheet. The observable edge is a propagation horizon, not a wall. Light stays at C, but expansion adds resistance. Redshift, energy redistributes, speed doesn't change. Every observer sits at the center of their own horizon. New lens, same universe, causality first.
Space loves to flex its rules. We look up, see the stars. We're told one number rules everything: the speed of light. C. It sounds like a wall, a forever limit, a cosmic do not pass. But what if it's not a wall at all, just a phase change, like the sound barrier once was? Here's the idea I want to explore with you today. Matter, energy, electrons, quarks, the whole quantum dance, lives under the dominion of light speed. But space itself? Space is weirder. It's stitched with nodes, tiny structural hints in the fabric. Reset, relay, propagate, call them graviton nodes if you like. In geodesic metrics, the way gravity curves space, these nodes show up as the scaffolding we surf on without even knowing it. Down here, I feel 9.8 meters per second squared. That's the Earth's pull, a rhythm baked into my bones. Out there, between planets, between stars, the local gravitational tune can drop so low it feels like zero. Nodes thin, spacing stretches. Space stops tugging as hard. So if matter is stuck under C, but nodes can reset, handoff to handoff, like relay batons, maybe the wall isn't the wall. Maybe it's a threshold we pass through with the right approach. Think sound. For years, the sound barrier spooked pilots. Shockwaves piled up. Planes shook. People whispered impossible. Then we tuned the aerodynamics, pumped enough thrust, learned the pattern, and whoosh, through. The sky didn't change. Our engineering did. So here's the provocative question. Is faster than light a social limit or a mechanical challenge?
The universe's speed limit, bold claim, faster than light happens all the time, and Einstein would still be cool with it. Here's the twist. Relativity does set a hard cap. Nothing can move through space faster than light. Try to push a particle to light speed, and the energy you need shoots to infinity. That's the cap on velocity. It drags energy and practical acceleration limits with it, because the closer you get to light speed, the harder every extra nudge becomes. So why am I saying faster than light happens? Because the universe has another trick. Space itself can stretch. You're not surfing across the cosmic ocean. The ocean is growing between you and everything else. Enter two ideas Einstein wrestled with. First, his equations needed a universal gear built in to keep the cosmos from collapsing. He called it the cosmological constant. Second, relativity demanded a universal speed limit for stuff moving through space, the speed of light. Two constants, two jobs. Now jump to the Hubble rate, how quickly space expands per unit distance. Today it's roughly 70 kilometers per second per megaparsec, which is about 43 miles per second per megaparsec. Translation: for every megaparsec, about 3.26 million light years. Add another 43 miles per second of recessional speed. Stack enough megaparsecs and the math gets wild. At a big enough distance, galaxies recede from us faster than light. That's not them breaking the limit. It's space adding more space between us. The speed limit is about motion through space. The expansion is the change of space. Think of it like this. I'm standing on a treadmill that's speeding up. My legs can't move faster than a certain stride, but the belt under me can carry me away as fast as the motor wants. The stride is light speed. The treadmill is cosmic expansion. Does that mean faster than light means there's a higher speed limit for the cosmos? No. It means there are two clocks running. Locally, relativity rules. Nothing outruns light, and nothing sends information faster than light. Globally, the metric of the universe, the ruler itself, can change, and that change adds distance without anyone moving through space at illegal speeds. That's why some light can never reach us. The source sits beyond the Hubble radius, where recessional speed beats light's race toward us. Not because light got outgunned, but because the finish line is sprinting away faster than the runner. Close the gap. Einstein's constants don't fight each other. They tag team. The cosmological constant sets how space pushes outward. The speed of light sets the rules for anything trying to hustle inside that space. So the bold claim stands with context. Faster than light recession is real. Faster than light travel through space? Still a no. The universe didn't raise the speed limit, it changed the road. And that's the coolest part. The cosmos can drag us apart at 43 miles per second per megaparsec, while the speed of light keeps our local physics honest. Same universe, two gears, one elegant rulebook.
Сочный дым, выдыхаем сладкого. Старый капитан опускается за бабками. Веер из купюр. Сочный дым, выдыхаем сладкого. Старый капитан опускается за бабками.